is Vera Kamera Lova with name 230291135. System of equation of two variables. The system of linear equation of two variables is a mathematical equation consisting of two linear equations, each of which has two variables, such as the x variable and the y variable. These variables only have a rank or degree of 1. General form of system of equation of two variables: ax plus by equals c. Description: x and y equals variable of rank 1. A and b equal coefficients, and c equal constant. Example problem using the combined method. Amir wants to jump ropes. Suppose the rope used turns out to be 70 centimeters shorter than his height. In order for the rope not to get stuck on Amir's body, the rope must be at least twice as long as the previous size. So when measured again, twins, the length of the rope will be 30 centimeters longer and Amir's height. Find the length of the rope used and Amir's height. How long should the rope be so that it does not get stuck on Amir's body? Elements. Suppose x equal length of rope in centimeter, y equal height in centimeter. Mathematical model of the problem. Equation 1 minus x plus y equals 70. Equation 2 2x minus y equal 30. Elimination of equation 1 and 2. Sin the y coefficient of both equations are the sum. It can be directly solved using the addition operation to remove the y value. Minus x plus y equals 70 plus 2x minus y equal 30. So the rules of these two equations are obtained. X equals 100. After obtaining the x value, substitute the x value into one of the equations to obtain the y value. For example, substitute the value into equation 1, then minus x plus y equals 70. So minus 100 plus y equals 70. Y equals 70 plus 100. So y equals 170. Based on the combined method, the value x equals 100 and y equals 170 are obtained. That it can be seen that the length of the rope is 100 cm and Amir's height is 170 cm. Next, we will fit out how long the rope needs to be for Amir to play jump rope without getting tangled up in his body. If the rope must be twice as long as the primitive size 2x, then we get 2x equals x times 100, so equals 200 centimeter. So the length of the rope needed to avoid getting counts on Amir's body is 200 centimeter.
System of equation of three variable. A three-variable linear equation is a linear equation that has or contains three types of variables. The general form of a three-variable linear equation can be expressed as ax plus by plus cz equals d, where a, b, c are constant with a, b, and c not but 0. Two or more three-variable linear equations with the same type of variable can form a system of three-variable linear equation. The general form of a system of linear equation of three variables can be expressed as a1x plus b1y plus c1z equals d1. A2x plus b2y plus c2z equals d2. A3x plus b3y plus c3z equals d3. An ordered pair A, B, C in bracket is a solution to a system of linear equation of three variables if the value of A, B, and C substitutes into its equation produce a true statement based on the explanation above. Some of the steps in preparing a mathematical model in the form of S.Pd are as follows. 1. State or translate the problem into language that is easy to understand. This is a real problem. 2. Identify the various mathematical concepts and assumptions used relate to the problem. This is a math problem. 3. Formula mathematical model or mathematical sentence relate to the problem. This is the mathematization process. 4. Formula S.Pd, which is the mathematical model of the problem. Okay, example, Eka, Dwi, and Tri are three siblings. According to them, the sum of their age is 28 years. The sum of Eka age plus 2 years and Dewi age plus 3 years equal 5 years plus 3 times 3 age twice Eka age minus Dwi age plus 3 age equals 30 years. Determine the order of their eggs from the youngs. Solution. Suppose Eka egg equal x, Dwi equal y, and 3 equal z. Mathematical equation. X plus y plus z equals 28. X plus 2 in brackets plus y plus 3 in brackets equal 5 plus 3z equals x plus y minus 3z equals 0. 2x minus y plus z equals 13. Obtain S.Pd, namely x plus y plus z equals 28. Equation 1. X plus y minus 3z equals 0. Equation 2. 2x minus y plus z equals 13. Equation 3. Step 1. Eliminasi x and y using equation 1 and 2 e and a. X plus y plus z equals 28. X plus y minus 3z equals 0 minus 4z equals 20x. Z equals 28 divided 4. Z equals 7. Step 2. Eliminasi y by using equation 2 and 3 e and a. X plus y minus 3z equals 0. 2x minus y plus z equals 13 plus equals 3x minus 2z equals 13 equals 4. Step 3. Substitute the value of z into equation 4. Then 3x minus 2z equals 13. 3x minus 2 in bracket 7 equals 13. 3x minus 14 equals 13. 3x equals 27. X equal 9. Okay, step 4. Substitution the value of x and z into equation 1. Then x plus y plus z equals 20x. 9 plus y plus 7 equals 28. Y plus 16 equals 28. Y equals 12. So the age sequence from the youngest age is 7 years, 9 years, and 12 years.
Method of solving the system of linear equation of two variables. 1. Graph method. In the graphing method, we will draw a graph of the two equations that we have created in the previous step. The easiest way to draw a graph is to find two interaction points of the x-axis and y-axis. 2. Elimination method. The second method is the elimination method. This method aims to eliminate one of the variables so that the value of the other variable can be known. 3. Substitution method. The substitution method aims to replace the value of a variable in an equation from another equation. 4. Mixed or combined method. This method is a combination of the elimination and substitution methods. You can use the elimination method to find the x value first, then replace the x variable with the x value that has been obtained using the substitution method to get the y value or vice versa. S.Pd solving method. 1. Substitution method. The solve a system of three variables linear equation using the substitution method. The following steps are used. Step 1. Cause a simple equation and express one of the variables in terms of the other two. Suppose the second linear equation is constant and we express x in terms of y and z. Step 2. Substitute the equation in step 1 into the other two equations to form a new two-variable linear equation system. Step 3. Solve the new system of linear equation of two variables to determine the values of y and z. Substitute these two variables to determine the value of x to solve the system of linear equation of three variables. 2. Elimination method. The step the solve S.Pd using the elimination method are as follows. Step 1. Cause the equation that contains the symbol from the variables, eliminate or remove one of the variables e, g, x in bracket to get a two-variable system of equation. Step 2, eliminate one of the variables in the two variables equation system I, a and y in bracket to obtain the value of one of the variables. Eliminate the other variables I, e, and z in bracket to obtain v value of the second variables. Step 3. Determine the value of the third variables I, e, and x in bracket based on the value of y and z obtained. 3. Elimination, substitution, or mixed method. To solve a system of three-variable linear equation using the elimination method, use the following step. Step 1. Choose which variable in the equation you want to eliminate. Let's say the variable x is to be eliminated. Equalize the x coefficient in the first equation and the second equation by multiplying the equation by a number so that remain equivalent. Subtract the equation from the second equation to get the first new two-variable linear equation. Step 2. Equalize the x coefficient in the first equation and the third equation by multiplying the equation by I so that they remain equivalent. Subtract the equation from the third equation to get the second new two-variable linear equation. Step 3. Solve the new two-variable linear equation system to obtain the y and z values. Substitute the y and x values into one of the three-variable equation to get the x value. Example, find the value of z of the following S.Pd. X plus y plus z equals minus 6, x plus y minus 2z equals 3, as x minus 2y plus z equals 9. From the existing S.Pd name, the equation it becomes x plus y plus z equals minus 6 is equation 1, x plus y minus 2z equals 3 is equation 2, and x minus 2y plus z equals 9 is equation 3. Determine the equation of x via equation 1, x plus y plus z equals minus 6 so that x equals minus 6 minus y minus z is equation 4. Then substitute equation 4 into equation 2, x plus y minus 2z equals 3 minus 6 minus y minus z plus y minus 2z equals 3. So minus 6 minus 3z equals 3. So 3z is minus 9. So z is minus 3. So that the value of z is minus 3 is obtained.